Hello, hello.
Hey,
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 guys.
we're
Hi.
here. Here we go. Here we go.
Nice.
We're here. We're following up a very long event that just took place, Storage Day, which was really cool.
I know,
Right?
right?
It was Storage Day. Some pretty cool announcements. They talked about the snow cone, which I want like 10 of those snow cones in my house. Just I don't know what to do with them, but I just want them.
Is it bad that I want 10 snow cones, but
Just
not
real snow
necessarily?
cones.
Yeah, real snow cones.
That's
I'm in
okay too.
Texas. It's 74 degrees outside. It's like, kind of perfect. So, yeah, I might have to go get a snow cone after this.
Let me tell you, in California, in Southern California, we're in like the low 70s. That's freezing. I need like a big heavy jacket. I can't handle it.
Yeah,
So,
well, you see that when it's not hot outside, my office is like ice cold, so I'm always like in a hoodie and that sort of thing. So yeah.
that's nice. So let's first of all say hello to our guests today. As you can see, so Jonah, you've been on the show before.
Yes.
Jonah, partner solution. I don't want to fill in any incorrect blanks.
For sure. I'm a partner solutions architect for containers at AWS. Also, I work with all the security partners, and I'm a maintainer of the open source project Falco Security as well. So
Awesome.
here for the color commentary on security and stuff.
I heard a question mark when you said container, partner solution architect for containers, and I was like, you should know that.
I was looking at my hands and the camera switched, and I was getting confused. Yeah.
Okay, so we can confirm, yes, containers.
Yes.
Yeah, container. I mean, it's basically Kubernetes now, but
Oh, nice.
Yeah.
And so above Jonah, to my left, I don't know. This is Chris from Stackrox, and I'm not going to say anymore. I'm going to let you introduce yourself, Chris, and we're going to be talking about some really cool stuff today. So why don't you tee us up and introduce yourself, of course.
Great. Thank you, guys. I'm really honored to be here. This is Chris Porter. I'm the Director of Solutions Engineering at Stackrox, which means I have a team of engineers like Jonah. Call us architects, call us engineers. We're a small company, so we wear a lot of hats here. And what we chiefly are responsible for is working with customers that are interested in Kubernetes security to understand what our product brings to them and how to use it and how to get the most out of it. We're proud to partner with Amazon to help customers improve the security stance of their Kubernetes clusters in AWS. And that's what we're going to talk about today.
Nice.
Fantastic. So what do you say? Should we just get into Brent? But actually, Brent, wait a minute. Usually you have some announcements before we go into things.
Good call. Thank you very much. So I feel like we need to call out, especially since this is going to be a Kubernetes centric show. We need to call out that KubeCon is coming up. And what happens right before KubeCon? We have our Day Zero event, which is lovingly called Container Day Kubernetes Edition. So it's going to be a free event, virtual, of course, and you can sign up for it at this URL down below, awscontainerdayk8s.splashthat.com. And join us. It's all day. We're going to be starting at sunrise and ending at sunset. Not really, but it's going to be a lot of the day. And I'm definitely going to end with a cocktail. So if for no other reason, join us just for that, for the happy hour at the end.
5 o'clock somewhere.
Exactly.
So, it's interesting, Brent. You and I, we've gone to events together and we've had cocktails together. What cocktail I'm going to be having, right? Like
yes,
it's a given.
I do. Mm-hmm, yeah.
But like for you, it depends on the mood and the scene. It could be a red wine. It could be like a nice whiskey. I don't know. What are you thinking of having?
Well, so when we went into the planning for Container Day, we actually originally it was going to be in Boston. We were all going to be together, all going to be in Boston. And so we're still kind of trying to honor that. And so I feel like I need to come up with a cocktail idea that, that is Boston. All I've thought of so far is beer. So I need to think harder. But yeah, I need to come up with like maybe an Irish whiskey cocktail or something that, you know, would be like that says Boston.
Or like a Sam Adams.
Yeah.
I don't know.
So, Irish car bomb with a Sam Adams or something. Yeah, totally.
Now we're talking.
Nice.
Okay. So let's just get right into it. And, you know, Chris, if you want to share your screen and we can just kind of, you know, jump into talking about Stackrox and all the cool stuff you folks do with security. Oh, thanks for pasting that, Brent. I almost double pasted.
Nice.
Drop a tea bag.
Yeah.
So
that is quite a level up, Josh, by the way.
Maybe what I'll do is give you guys a little bit of a background on what we're talking about today, and then, you know, illustrate all that with a product interface here. You know, what Stackrox is, and I'll bother everybody with a little bit of PowerPoint here just for a moment. You know, I'm not a PowerPoint guy, but I want to talk a little bit about, you know, what the product offers and why our customers are choosing this. You know, what we basically are here to say is that Kubernetes that you're using today as an API for managing infrastructure, right? And traditional tasks that, you know, we attribute to the infrastructure like scaling and, you know, consistency and portability are actually good controls that you can use for security too. So if there's anything that's just about us, is we want to help you use Kubernetes for all you can get for security. We think that you can leverage the platform, the controls that has available to reduce risk, to make your security teams happy. If you're you know, DevOps focused, you can get security in a DevOps nature, the same kind of way that you're building code and fixing bugs and improving performance. You can think about security. And for the security teams, I think you can actually get better security than you could get in traditional environments, right? You can leverage this declarative, immutable model, right? This idea that I build from code, I deploy multiple times. Like that model, you can actually get to better security than you could in traditional architectures. And that's what we're going to talk about, how to do that here. Now, for the folks who have a security background, of course, security is broken down into a bunch of different tasks. You know, you have everything from, you know, end users, endpoint security. We're much more about the Kubernetes application platform and your security in it. Hopefully everybody can see that. So we are going to talk about Kubernetes security at the build phase, right in front of the developers. We talk about empowering the developers to give them the tools that they need to build better, more secure applications. We're going to talk about using Kubernetes to enforce some of these rules, right? Security at some point has to draw some lines to say, look, this is not something that we're willing to accept. This risk, we can't have this running, right? So the deployment time is going to be an important place for that. And then a runtime, because your applications are going to be constantly probed by insiders, outsiders, you know, unwelcome visitors. And so, you know, continual observation of the platform is going to be important. Now, before we get into the demo there, I also want to, you know, point out that we're going to be at reInvent. We're going to be at KubeCon. We've got a presence at all of these things. We're an Amazon partner. And so we've been, you know, since the company was founded, have had a presence this year virtual, but we're looking forward to the opportunity there. Another thing that we're excited to talk about is that recently we announced a new platform, a new open source project. The first one, you know, officially from Stackrox here, called KubeLinter. You can check it out on GitHub. We'd love to have people taking a look, filing issues, filing pull requests, making use of it, giving us some feedback. If you're familiar with the concept of linting, you know, files and source code, you'll be really familiar with what the output looks like here. Produces for you essentially the line-by-line analysis of you know, security issues, mostly with you know, kube YAML files that you supply. So we'll talk about that. We'll talk about how, you know, we address those things. But the rest of this is all pretty technical. You know, I'd like to show off a little bit about what we actually get. What is Stackrox? Because sometimes you know, you look at these slides and you go, I have no idea what these people are even providing us. So really simply, Stackrox is a security software company. We sell software. You run the software in your Kubernetes clusters. And unlike most software products today, it's not offered as like a hosted service where you log into our dashboard, you know, hosted somewhere. You're going to be running this in your EKS clusters. And the reason for that is really that the stuff that we're handling here is sensitive, no doubt about it, right? We have customers that are achieving things like SOC 2 and PCI certification They're handling data that is, illegal or at least highly recommended against to go out and disclose. And for a lot of those customers, frankly, not having a vendor with fingers in the application environment is really pretty convenient, makes it easier. So we run this, we don't run this on behalf of your customers, but we do provide the software, the expertise, and the help in getting it running. But we're not here to stick our fingers into your product and application.
I think that's a good point. There's a lot of products out there that are run as a SaaS, and tons of enterprise customers, they go in asking, can we get this on-prem? On-prem meaning we run it ourselves. So I like that you've, kind of just started from that position.
That's right. Yeah, I mean, it comes out of work with sensitive industries, government, who have, that policy just in general. Or, I mean, if you look at what's required to achieve something like PCI certification, you have to get all the vendors that supply to you, right? And Amazon does a great job of providing the documentation for AWS, and you combine that with your controls and anybody else. But really anything that's involved, maybe you've hired an outside managed service provider for security incidents, right? Like a tier one, emergency responders for security incidents, and they have access to this, and they have to be cleared, and they have to meet your requirements, and you have to maintain that documentation. So not that we wouldn't be up for it, we are, we run a good ship here too, but we also just want to relieve our customers of that burden to have to keep that up to date with us. And let's face it here, what we're going to be looking at is some seriously sensitive stuff, right? We try our best to make sure this product is not out there, leaking information or accidentally disclosing information, but it's almost like you've given somebody access to your AWS console here. I've got, at a low level visibility to everything that every container is doing. In this environment, Stackrox is running in my EKS cluster here. You can see my ELB hosting this, and I've got two clusters, in fact, both running in US East. But we talk about security management. The security team, first and foremost, is going to want to have visibility, and that means everything. So the product is designed as a very lightweight Kubernetes deployment. In fact, as we go through, poking through here, we can actually go look at what Stackrox is actually doing inside of each cluster. You can observe our own network flows and everything else. Full disclosure, because a legitimate concern is, are my security tools actually increasing my security risk, right? You've got these highly privileged tools of visibility into everything, and attackers have been known to exploit them. So we want you to feel confident that these are built in a way that is going to be resilient to that, and not going to disclose that information. But the way I like to preview this product is actually that there's two products here. So while we'll be looking at what the security team is going to need and want, we're driven by what the developers are doing. And we thrive in environments that are developer-centric. If you're thinking about building applications in an infrastructure as code way, then we have to think about how to fix things. How does security fix there? I mean, if you're literally not allowed to patch a running environment, how do you resolve security issues? And so the answer for us is always going to be, go fix it in the code. Go fix it in Kubernetes, right? Go fix it in your definitions. Go fix it in the way you're defining things. So I'm going to talk about other interfaces, right? The way that developers interact with this product is going to be different than the way the security team does. This happens to be Jenkins, but I've got, a half a dozen other CI/CD pipelines. The idea
Code
here
build?
is, I'm sorry?
Code build?
Soon, yes. If you take a look at our contributions repo, it's only because I just haven't done it yet. I haven't done it yet. So
if you've done one of the other Circle CIs or one of those, code builds should be pretty easy.
That's right. So the way that we've approached this in a very generic way, it's literally just down to, how do I get my environment variables in there for my auth tokens? How do I get my output in a removable format? And so on my list. In fact, my team is kind of working on this as we go. A lot of what makes Stackrox go is going to be integrations with other products. And so we've been publishing those on GitHub to make sure that, if we've got some expertise and some skill in it, we can help you build that and we can help you get it running. I picked Jenkins because it's the granddaddy of all of this, and I've been using it a long time, and love it or hate it, it's out there.
Adam loves it.
So what we're trying to do here, it really is the same model in any CI/CD pipeline. let's empower the developers early with information that's relevant to them. There's nothing worse than a security tool that just black holes something, right? Something disappears, there's no log, there's no error message. I would say slightly better than that would be a log in a proprietary product, like having to come into our dashboard. We're actually just trying to avoid that. You're going to get this output here. We're going to send it to you in Slack. We're going to send it to you, file a Jira bug. Like the idea is to explain clearly like where the problem is and why you've got to fix it. So the security team gets to understand like, hey, I don't want to let you bring in this image because it's got a version of Perl with a really serious vulnerability in it. First of all, I'd ask, what are you doing with Perl? But secondly, I would ask, why is this vulnerability still in here? And what do you have to do about it to resolve it? So we're making it clear that there is a quality gate that you have to get past in order to you must be this high to ride, right? And we're doing it in a way that empowers the developers, right? So, development teams are not unaware of security, and they're certainly not, uneducated about things, but they like, this is not their top of mind, right? And so we want the security team to be able to, to put those constraints in place. But, more about that later, because we're going to talk a lot about how we're going to resolve those things. So the security team's job then really is to figure out, where are my problems, right? I don't know enough about Kubernetes. Maybe I don't understand anything about containers and how they're built and deployed. So where are my problems? And where's that risk going to jeopardize things like compliance? Or, do I have a breach in progress? We've got these high-level goals that the security team has to reach. How do we get there, and how do we give them that? Well, security usually starts with vulnerabilities, and this is probably old hat for everybody. Like, vulnerability scanning has been around for a long time. There's a lot of products that do it. In fact, the ECR registry provides security scanning results in Amazon. And all I can say advice-wise is make sure you use it, right? That the vulnerability scanning is one of those basic hygiene things that you need to do. I actually think the better approach is you should really rationalize what you're bringing into your container environment, and frankly, dispense with everything that you don't absolutely need, right? This is a pretty typical example here of a Docker file that just pulls in a base image. This is probably Ubuntu or Debian. And it comes with a lot of stuff that is just going to give you grief. So better than vulnerability management is a vulnerability management process, right? Where you're checking for this stuff and getting it fixed. Do that often. Don't do this. Don't leave your images sitting around for 3 years. But best of all is slim your images down, or choose these distroless or even scratch images if you can get away with it. If you're not bringing it in, there's not going to be a vulnerability, right? People ask, well, okay, if I don't have things like like wget and curl or a shell in there, how do I log in? How do I troubleshoot these things? Well, you shouldn't be, first of all, right? You shouldn't be logging into a production application. Like, these are some of the controversial things that usually causes the audience to get into a stir.
It's definitely a shift, I mean, I've had that conversation before, and it's controversial because people are just used to doing it a certain way. And once you can sort of, get them out of that habit and introduce the new way, I think it's totally accepted and people like it. Log your exception instead of logging in to read your exception. Send that off somewhere to get processed rather than having to rely on a person to go and collect it. Things like that are they aren't that different. However, it ends up opening the door to a completely different world where you don't get SSH access and you don't get the ability to log in and make changes live in production and things like that. So it introduces a ton of good practices, but it does require a shift in the way that you're used to working with things.
That's right. If you're execing into a container to troubleshoot something, there's a mistake in your operations and troubleshooting approach there. And in most security environments, in let's say a Fortune 500 company, they're going to treat a developer logging into a production application via SSH or exec as a security breach, right? Like you as a developer are not allowed to access payment card handling data, right? That's not something that you would need to have. Companies go to great lengths to to build data sets they can test with that don't have any of that, have all that information struck out. But there are some cool things that are happening. We talk about things like removing as much as possible. You should use things like init containers, right? Init containers are a great way for setting up the environment, especially if you have like network file shares and permission changes. The stuff that you're not letting your main container do, but you do on the side. And then I think in 1.19, Kube 1.19, the idea of ephemeral containers. I mean, they're all ephemeral, but the idea of firing up a temporary container to attach like almost like a sidecar that you're temporarily building to troubleshoot something is a really promising approach that, again, like we're big fans here of using the platform for best result. And whenever I deliver a webinar and a talk and I talk about building better EKS clusters, we talk about reducing management interfaces. And the first thing I say is you should stop SSHing into your instances, right? It should not be possible that the agents shouldn't even be there. And that one causes that's usually fighting words, People are like, how do I troubleshoot anything? So the topic here then is purpose building things for containers, and Kubernetes. On the other hand, like not all of that's realistic. We come into a lot of environments that are building things the same way. That memory cache that I pulled down from Docker Hub works great. It's really convenient, and like I'm not going to change it. I don't have the time. We know that there's going to be business priorities that sometimes overrank the security decisions. So what we're trying to do is help the security team understand just how much trouble you're in. And so when a really common thing comes up, like new vulnerabilities out there, could be anyone, it could be new, it could be old. One of the first questions is, how widely impacted am I by this? And that's a hard thing to do in most environments, right? You've got to scan a lot of different sources. Containers somewhat make that easy. And this is a good example of what we call risk. So here's a single vulnerability that's in 5 deployments, but I've got this different risk priority. One of the risks that a vulnerability would be exploited is it up and running in a container somewhere, right? I might have 7,000 images in ECR, but I've got only 6 containers that are running right now with that vulnerability. So that's the idea, that there's lots of other things about a running Kubernetes deployment that either increase the likelihood that vulnerabilities are going to be probed and attacked and breached, or if they are breached, it's going to give your attacker a lot more to go on and a lot more value and a lot more data. So what we call risk is really nothing more than the simple combination of configuration and privileges and network access that says, hey, this one is going to get attacked, right? Or maybe it has been attacked already, and we're looking at some of that behavior. But these policies here, if they look familiar, you're going to see things like privilege container, right? And that's where back here in Jenkins, I got a little bit of a notification like, hey, you're not allowed to use privilege containers, right? We're going to feed back this, hey, this is an undesirable state in your running environment. Let's go figure out a way in the source code to fix this, right? Privilege container is something that should be used very, very sparingly. Now, we know there's going to be exceptions, and unfortunately, like that's the nature of security, right? It's not a setting, it's a process, and it's about understanding, it's making exceptions where necessary. There are some things here, of course, that I would never want to see ever. Adding kernel level, privileges in the capabilities in the kernel. There's our port 22. Don't even try it. Even things that are often hidden to most kube admins, which is what is my service account running as? So we've seen a bunch of privilege problems with this particular deployment, but this one probably takes the cake. This is something that, when you go out and look in the world of Kubernetes security, one of the best resources that we've found that kind of validated a lot of what we were talking about was last year's audit by the CNCF of Kubernetes. And this report was fantastic. I mean, it's good that CNCF is taking a serious look at the Kubernetes code base, and that they're fixing bugs. But part of it was this kind of sobering analysis that Kubernetes is a really complicated system with a lot of defaults that are set kind of weirdly for security. They're bad defaults that you need to get past. And that in some cases, things like roles and service accounts here interact in strange ways that can cause you really, a huge problem. So what we're doing here is trying to highlight where that risk is, and essentially under the hood, those policies try to communicate back to the teams how to resolve it. So of course, I've got lower risk. You can decide where your your tolerance for this level of nightmare is. As I go down the list, there's just less going on. One of the things too is that it's not all doom and gloom, right? Security is usually full of bad news, but there's also some really great features of Kubernetes and of Docker containers that we think you should be using that will help mitigate attacks. One of my favorites is this one. Frankly, you should use a read-only root file system on your containers. Your developers should not be under the impression that any file that they write is going to be around for any period of time. So if you're checkpointing, if you're writing PID files, that's my favorite. If you're counting on state being transmitted in the container through files, you're already making a mistake. So, storage is a whole nother topic. You should be storing things and checkpointing things properly. But at that point, you don't need to write anything to the file system. Your image should have everything that it needs to execute. So just make the whole root file system completely read-only. And you eliminate the possibility that someone is going to write to /bins, the user bin, to home and execute something, right? There's just no way for you to do that. Similarly, things like Linux kernel capabilities, right, which are broken out, and the Docker engine has a default set of these privileges, and frankly, a lot of them aren't necessary. So we talk a lot about that, like these preemptive things that you can do. The writing the file system is a pretty important one. If I can't write to the file system, that's a whole slew of attacks that follow the pattern of dumping a payload to disk and executing it are basically eliminated. So
go ahead.
Go ahead, Adam.
Well, so you mentioned this in the CI pipeline.
Yep.
So with this data, if my organization, our security posture deems that having we don't want read-write file systems. If anything's running as privileged, we should stop your build. So can I take that data and then in my pipeline actually stop the build?
Yeah,
and halt it?
Absolutely. So there's two things that we can do to enforce that, right? And I'll actually just jump ahead and show you what a policy looks like in Stackrox, right? And that read-only root file system. So the best thing, obviously, for security, this may be a new topic for teams, and so we want teams to assess it. Right now, in my demo, by default, I've got just an assessment going on, and in fact, I'm sending those results over to Security Hub so I can see, here's my read root file system being violated, so I can consolidate that with other information. One of the great things we can also talk about would be use metadata in Kubernetes. If you can help the Stackrox software understand how important this application is, we could raise the level of visibility there. We know a little bit about it from the metadata. But let's talk about enforcement. In this one, for one, I am excluding some of my deployments because it's just not realistic everywhere. The description, the rationale, and remediation, as we call it, is all customizable, but it's there to explain to the developer what this means and how to get there. And then the enforcement is going to be at the build time or at the deploy time. And we distinguish this, it's kind of an artificial distinction. They're both before it gets to Kubernetes. But what I mean by build is here, right? You can see that I can actually provide feedback that doesn't result in a failure. You'll see that some of these here cause the failure, but I as a security team, I can decide the line between warning somebody about something versus, hey, this is not going to happen. So the CI build will fail, but we don't think that's enough because there's going to be stuff that bypasses the CI pipeline. An attacker doesn't care if you've got a build enforcement set. So we're actually going to instrument Kubernetes itself. This is where native platform enforcement comes in. Kubernetes has an admission controller. You've probably come up against this if you provided badly formatted YAML. It just spits it back at you and says, I don't know what this is. You're trying to submit something that's incorrect. So we're using that feature here to give it a security audit before it goes in. And we like this because it's clean, right? It fails fast and it fails very clearly. It prevents the security, the containers from actually coming up and running, right? So you never see the incorrect configuration make it live into the environment. And of course, the development team knows that this deployment didn't get created. Whatever the object this is not there. I can use kube control and I can go in and I can actually find that. In fact, I've got a live demo. We can actually see what this happens here, right? So, when I'm running a kube control, when I'm running something like this, I'm just going to bring up a shell. This is just in Ubuntu. I'm just going to try to run, bin bash. I'm going to do all kinds of bad things here. But I'm going to go and try to create this. The image is going to get scanned, and then boom, like I've got a problem here. This isn't even a deployment file that I'm supplying. I'm just literally saying go and run this. But because Stackrox gets a piece of every new object created and even updates, right? So if somebody's editing a deployment in place, you can actually snag that and say, hey, this one actually got rejected because it turns out those 3 Perl vulnerabilities have recently become fixable. But if I was trying to run this as privileged, if I was trying to run it with a read-only root file system, I would, snag all of those. So subtle differences, but this is where I'm actually going to the point where maybe I don't even have any idea about Stackrox. I've never even heard of it. But in my environment, I'm going to get this feedback, and I know this thing didn't get created. Of course, we do have that, that pre-flight check, right?
Yep.
So you're going to get this pre-flight check. So if you're smart and you want to get a prep version of that, just to say, hey, show me this, and anything I might do. Again, what I like is that we can deploy things here and get a sense for what Stackrox is going to think about it, or we can get that pre-flight check just so that we know beforehand. You're also seeing down here one of the other things that we have where we've created a break glass procedure. It's optional, right? But sometimes there's a push in the middle of the night, there's a fix, things are offline. So this is a way of saying, I get it. I know I'm breaking the law here. It's going to alert the security team, but it is going to make sure that I can get past those policies. Entirely optional. So for security teams that are worried about everybody, using that regularly, but it is a nice relief valve if I need to get past that. There's another.
That's fantastic.
There's another great example. I'm sorry. Go ahead.
No, that was it. I just wanted to say that was really cool. That break glass is such a real scenario, right? Like there's gonna be times where you just have to get in, and by having that output right away, I can see, okay, this is an emergency. Yep. Here's my ticket number. Here's my annotation. Now I'm in, and then the security team gets notified, and they have a record, right? It's all about record.
Yep.
Having that record for security audits. So very cool.
I think we've done a great job with, our product management teams, engineering teams have a lot of experience running these kinds of environments, and the challenge of DevOps driven, pipeline driven applications. And there's a question here about like what happens. Here's one of the most difficult situations to encounter where security and dev need to work together. I've got a new vulnerability, I don't know which one it is, but let's just go search for all of them, right? And it's in my live environment. And the way that Stackrox, by the way, to answer that question, under the hood, we're always updating the vulnerability data. So the vulnerability data reflects, what's live, right? This actually happened to us last week. Literally those 3 Perl vulnerabilities that we keep seeing was just fixed in an Ubuntu package like last week. So they've been out there for a few months. Finally, there's a fixed version. So our little policy criteria flipped and said, hey, this is fixed now. So what do we do about it? I mean, like these are situations where, if it's on the news, that vulnerability is actively being breached, you're going to have human beings involved, and risk again will help you assess, like, are we protected against that? Are we using read-only, file systems and other protections? So the idea of like how much hair on fire do we need to be to get this resolved right away can be answered here pretty easily.
So I've got a quick question. Oh, yeah. Sorry. So in the event that you had, let's say, like 100 policies and this fix comes, is there a way you can like automate, or do I have to go click through all 100 and edit it? Is there like an API we can fix these all really fast through?
Yeah, absolutely. So there are bulk updates. I should have previewed with the fact that everything here is code driven, of course, and API driven. So while I'm looking at a nice web form here and fields that I can fill out, everything is exportable, importable. Everything is just JSON objects in an API. And for a lot of things, you'll see things like being able to change my notifications. I can go in and update these in bulk. So we find that a lot of folks are using the UI here. Bigger organizations are generally integrating this in with, Security Hub and Jira, and hardly ever spend any time in it. So here I can enable Security Hub in bulk. But yeah, we believe strongly in policy as code, right? So all of these are going to be managed in that way. And while the UI is pretty convenient, it's all driven under the hood here with a RESTful API. So
I have a question.
Yeah.
I was noticing early on, and I still see it up there in the header, 2 clusters.
Yep.
But you talked about it earlier as being something that runs in your cluster. So
Yep.
It sounds to me like I can run it in one cluster and maybe manage other clusters. Is that a possibility?
Yeah. So I did exactly that. And this is a very common use case, right? And one of the things that, there's advantages to running everything in one big environment, I suppose, but most of my customers run things in certainly separate prod, staging, dev environments. Almost certainly you're going to have different regions around the globe if you're an international, serving international clients. So you're going to end up having more than one place. And security is, going to be important across all of them. So I've got just 2 clusters here because, well, EKS clusters aren't free. So set them up for this environment here. I decided on some of the options. And a really common use case would be to distinguish these because, hey, in dev, anything goes, right? Bring in those images, experiment, play with these settings, but just be aware that, in production, you're going to get some other choices. You also have some different options on some of those enforcement options that we looked at, like admission control. I'll say that most folks aren't brave enough to go starting, to do enforcement on updates. Although, I wonder, really, should you be editing your deployments live? But the different clusters are treated a little bit differently. They're also treated differently here because, some of the Kube network federation stuff is happening or where, but in general, Kubernetes networking is going to be per cluster, right? Our domain here is to look at what your deployments are doing and the pods are communicating. And, in each one of these, I'm going to have that little bit of Stackrox stuff here. Actually, this is my production cluster, so it's got this is the deployment that we're actually logged into right now. But our domain here is Kubernetes, and Kubernetes communication between the pods. So what you're looking at here is something that's not typically visible to most security teams, and it is distinct from anything that you might be doing with VPCs and security groups, right? We're not in that space here. We're just looking at what's going on among the the individual deployments and namespaces. Now, the reason I'm showing you this is, well, one, again, that visibility idea, like who's talking to what, where's my front end system coming in? Who's making those DNS requests? But also, too, to help show you that you've got a problem here with your security controls, that you've got things like a Postgres database and, you're receiving connections on port, 45432, let's change 24 hours. I've only got one flow, in other words. But if I look at what Kubernetes thinks about the network policies, we've actually got things wide open, right? So in security, the gap here is you've got your networking wide open and, the port's not using it, right? So this is one of those challenges that with Kubernetes, the default is made for productivity, right? It's made to be useful. It's made for services to communicate with each other. It's not made for security. And there's a way to resolve that. And this actually, I think, illustrates what we're trying to do here really, really well. That we want you to meet compliance standards. We want you to have some, sanity on your networking so that somebody who compromises this WordPress deployment on the front end can't get into the back environment. But we want you to use Kubernetes for that. So this illustrates what we're trying to do, right? We're not trying to provide you with a firewall, right? And I'd be wary of any solution that would try to replace something that's part of Kubernetes. We think that using the language that Kubernetes provides here with network policies is good for security. It's good for auditing. It's good for your developers, right? Because this is code. This is something that I can get my teeth around. I know what this is. I might, hate the extra work that comes along with it. But if I'm going to do security firewalling for my applications, it should be in this code-driven way. And then lastly, for operational risk, right? There's no Stackrox firewall that's going to fail and cause an outage with the networking. It just doesn't exist. We're not here to be an alternate source of truth in your cluster. We want Kubernetes to be the source of truth. We want Kubernetes to set the state. And that's what's beautiful about the whole system is this declarative interface. And you can state the way, you want your things to run. And a lot of that can be used to really good security advantage. So you'll see this, banging the drum about this a lot. Like, use Kubernetes to the best possible security result that you can. And then later on, when we're talking about higher level goals, like, is my payment card information secure and isolated? We can measure these controls precisely and provide you with a detailed report that you can hand off to an auditor. So
nice.
Yeah. So fix it in the code.
So
is there a question?
I like that multi-cluster question. Is there any, can you tell us like how that's actually getting data from the other cluster? Is it just like a CRD, or is it like a REST API it's pulling from, like a service that's deploying? Like, how is that getting all of that?
So the data that we're gathering here comes from a few different sources, and you can see the little components here in the UI. Again, full disclosure, right? So what we call the collector, kind of self-explanatory, gathers data from the underlying nodes. It's a daemon set, which means it runs one pod per node. And we're essentially grabbing a little bit of resources, tiny little bit of resources, but we're mounting host file system, process, kernels. I mean, this is a high level of access. We're doing it mostly read-only here. We've got network policies that deny access, so we're following our own advice here and restricting access to this. So this is what gathers all the runtime information from networking and process activity. The sensor is a separate pod that talks to Kubernetes, right? This is looking at the Kubernetes API, and it's limited in its network policies, only allowing the collector and the admission controller to talk to it. All that stuff gets forwarded on. It's all using TLS and gRPC to send everything over to that central. So I'm doing in my demo environment what you should not be doing, which is running everything on the public internet. So VPC peering, that's an architecture question. It's a big topic, but we need a TLS connection between the components. Now, we know organizations don't always have that, right? Especially if you've got multiple regions and you don't want to transport security data, where you've got different business units. And to be honest, it's fine. There's nothing that requires that you only run one dashboard, and the data and the policy can be driven by code elsewhere. But it's designed if you want to have this multi-cluster view, the ability to do that. So
it's a really cool feature. If you didn't have multi-cluster view, it would probably be your #1 most requested feature request. So it's awesome that you have it. And so if you combine that plus just the fact that this is running in cluster and not a SaaS, then like all of the customers that I talk to that run disconnected Kubernetes clusters, like EKS, how do we refer to it when you don't expose it publicly?
Is it just private clusters?
Yep.
Yeah, private EKS clusters. Like all that comes into play, and having this level of management and this level of view for a security team, I can imagine being like just next generation. It's huge win.
Yep.
Yeah, no, I was just thinking like how actually great that is as well. Like I've seen it with SaaS for sure. Like some SaaS things can connect to multiple clusters, but it's its central brain. Like being self-managed and finding and talking to other clusters is huge.
Yeah. I mean, your security needs are going to change, right? That vulnerability that wasn't super important yesterday, now suddenly, either it got reclassified or people are using it in combination with other exploits. I mean, we never know where it's going to come from. The incident response here is designed. I mean, incident response is something that we provide here for understanding what happened post-mortem, because the containers are going to disappear. And again, like we never know what you're going to be looking for. So we're trying to be exhaustive in what we capture here. Now, a lot of our customers, to be honest, like already have well-established incident response systems, and that's another thing again that we can do is get this data out to an external system and handle the eventual decision making and the follow-on that enables. So whether it's a SIEM tool, it's traditional ticketing systems or what have you. Somebody I know in the chat asked about like, well, what happens if I go and modify my containers? I run a package manager or something. Well, guess what? We got you covered. What we don't like to see is anything that violates that mutability, right? In fact, containers aren't VMs. And so a lot of the runtime signals that we can look for are the things that you would see it being at home in a VM, like package managers being executed, somebody adding a user account, right, modifying a password. These are things that, like in a virtual machine, they happen with managing users and passwords, but you shouldn't be doing any of that in a container. These aren't made to to be general purpose. So we're looking for those kinds of signals to say that, hey, somebody's either doing something really wrong or they just don't get containers yet and they're still doing something wrong. So whenever we talk about how are we handling things after the fact, I got a lot of this one here, right? Everything's running as root. This one is going to come up again and again. In fact, this one is so noisy sometimes. I mean, it's legitimate, but it is noisy because everybody does this. Everybody runs their processes as root all the time. And, you're kind of counting on container segmentation, separating things. But we're going to point your developer towards, hey, there's an easy way in a Docker file or in a pod security context to change the user to a less privileged one, and you avoid a whole host of issues that way. With running things as root, you're doing the privilege escalation for the attacker, right? So let's not set things that way in the first place.
I think you're right for sure. I'll start with that, but the complication comes into play with to be really effective, you would want each of your containers to run with a unique UID. And how do you negotiate that? That's something that, like we get randomized ports, but we don't have randomized UIDs. I wish that was something that could be built into the engine. Because if everyone ran as UID 99, then they're just as privileged as everyone else if there's ever a breakout, so they'll have all the same privileges to be able to go and read all the data from the other containers.
I wonder if you could pull a timestamp and change it into a random number on container startup. That would be interesting.
Yep.
Yeah.
Maybe I'll get started on that. Open source pull requests. We'll get into Kubernetes and develop a process to randomly generate it. It'll be like chaos user IDs.
Nice. I feel like I saw a question pop through, but I haven't. I missed it. I don't see it anymore. So forget I said anything.
So I'll jump around a little bit. I saw a couple of things about runtime and stuff. We didn't do that a whole lot of justice, but the description really is that containers. To me, I feel like the less of the runtime intrusion detection you're doing, the better, believe it or not. That if you can get to a point where your containers, your deployments are so constrained by the configuration that you've provided, right? Think about it. In this magic world that I'm envisioning, your images don't have very much surface area on them. They don't have much stuff to run in the first place. They don't have shells and system utilities and things. They're lighter weight as a result, and they're more secure. And then on the other hand, you're using Kubernetes to prevent writes to the file system. One of the secret weapons I talk about is Kubernetes egress network policies, right? Your pods don't need to go out to GitHub, I hope. I mean, probably, right? Like if they're not egressing the environment, you're making it hard for an attacker to phone home, to go and download a crypto miner. So we're going to try to constrain that as much as possible. That being said, runtime detection and response is going to be required by any organization and by compliance. But we can use that container nature to look at things like, what are the containers in my pod doing? What are the different replicas doing in my environment? And has anything changed? And that's one of the things that we're looking for here is that, I've got this really boring Java application, but then later, like hour later, days later, I see a change. And either this is somebody with a cron job in the container who doesn't understand containers and still getting used to it, or I've got something happening that I don't expect to see. It's unusual and it's worth noting. Now in this UI here, the little paint color just means, hey, we found this thing. You might want to look at it. We're not actually doing anything about it at the moment. We are just trying to highlight that it adds to risk, that this kind of behavior was allowed, this kind of behavior went through. There's my package manager, right? I don't like package managers running. So we're going to highlight that. But the idea that this is going to change, your behavior changing over time is not a good signal, can be used. And you can use it in combination with any of the other criteria that we look at. One of the cool things is that, we talked about security exceptions, right? Like to be usable, a security rule cannot be a blanket rule. You're just going to end up turning it off because it'll stop some business goal from being achieved. But I can say that, hey, if this is in my production cluster, I want to be a little bit more restrictive. Or if it's in a payments namespace or labels or whatever, like I had to put some policy exceptions in earlier around things like Jenkins, that shell being spawned by a Java application. Well, guess what? Like Jenkins is a Java application. It spawns shell jobs. And so what I did is I just went in and said, hey, in the development cluster in the Jenkins namespace, we're going to exclude this so I don't get flooded with things and I don't get false positives to go in and cause Jenkins to stop operating. Now, if I did want to stop this, at runtime, the way our policies work is, of course, we're monitoring all those things at runtime. We see the process getting created. In this case, I'm just matching the process ancestry. So, well, we have enforcement here too, and you guys may have seen this earlier, but here in runtime, we're going to tell Kubernetes to nuke this thing, right? This is our runtime enforcement. So there's going to be, a lot of questions like, why don't you just stop that shell command? Why don't you just stop that network utility? Well, now you're at this point where your app is doing one thing and Kubernetes thinks another, right? This is what we want to avoid. We want to avoid breaking your containers in new and interesting ways that Kubernetes can't recover from. So you're not depending, I hope, on your container sticking around and being permanent. So we're going to kill the pod here. We hope you didn't need it. But when this runtime incident occurs, it wipes the attack out. It takes the container out and allows Kubernetes to recover. So this is the life cycle that Kubernetes expects. And we think that security enforcement should be in line with that life cycle planning. It's just a different way of thinking about it.
So one quick question, and we hear this a lot, is if that happens and you kill the container, do you lose the history in that forensic data for like a post-mortem later?
So not in this case, because a policy violation results in, a violation object being created in here. So whenever that event occurs, you're going to see it here, and you're going to see it in the Stackrox interface, which means that it'll push to Security Hub or wherever else you have it going. There's one other place it goes, which is into Kubernetes, right? Because there is an event stream in Kubernetes. And again, whenever we take action, it's a Kubernetes action, and we're going to log it there as well. So that's again, like if you've done everything you can to ignore Stackrox in your environment as a developer, you're going to run into it at some point, right? You're going to run into it in Kubernetes, and you're going to see, holy cow, what happened to my pod? Like you're going to get knocked out of that session, and you're going to see the event stream in there. So the only other thing to talk about is actually something we've already talked about, which is compliance. Compliance is, probably the number one driver of security requirements, right? And it's a good thing if you are thinking about establishing a security process. Some of the container-specific requirements from NIST 800-190, these are good guidelines for how to approach image and deployment and lifecycle security. All of these things in Stackrox are written in terms of, how does the Kubernetes platform provide these controls? And I deal a lot with PCI, with retail and finance. And, when it comes to things like networks, network diagrams, restricting access, we're really just talking back to the same topic we were talking about before. Use network policies. These are easy to audit. Your auditor may not be familiar with them, but they're a standard and they provide for the controls here, and they're easy for us to go and measure. I'm doing terrible in this environment, but the restrictions here can be translated into Kubernetes network policies. And of course, the other things, don't run unnecessary services. Well, again, like Kubernetes, we can detect both configured services that are listening on ports, container ports, things like that. And we know, of course, the runtime traffic, and give you a comparison between what you think you're running and what you're actually running. And then, the biggest goal of compliance, of course, is to find somebody to blame for all of this. So we'll give you the reports by cluster, by namespace, down to the deployment, like, hey, you've got work to do here. And then, of course, because all of this stuff, if you are going to actually, go out and seek real compliance certifications, you're going to combine this with all the documentation that AWS provides for your environment on the physical and the hosted environment there, and you're going to combine it with stuff like this, which is what your auditors are going to want to see, right? The gory details of, this is output from the Stackrox platform that shows you for every single object in your environment here, where you're failing those controls, right? This is the kind of thing that your auditors are going to want to see, and it'll at least keep them busy for a while. So
nice.
Well, so that was quite a bit. I think we have to start wrapping, but that was really amazing. I just want to say, Chris, you took us from, kind of our CI process, just when you start, even local development, right? We were able to see if we had any problems there, all the way to runtime. So, and it wasn't just, CVEs. It's more than that. CVEs aren't the only aspect of security, right? It's also the human that's creating these objects, and oftentimes we're the ones that make mistakes,
usually
that put us at risk. So I think it catches both. Oftentimes, usually, I don't know, but anyway, that was really cool. So, Chris, is there anywhere I guess folks can go to sign up for a product?
Yeah, absolutely.
Trial,
so
anything
we
like that?
are easy to work with as a company, and Stackrox.com will have everything that you need there. I urge everyone to check out the GitHub repo that we have as well. But Stackrox.com has a blog. In fact, there are articles up there on EKS security that we've talked about, network policies and other details. Some of those blogs have made their way to the Kubernetes website as well. But if you reach out to us on Stackrox.com, we'd be happy to give you a personalized demo. And this is a product that runs in your environment, and we're happy to give you a trial and run it and see what it can uncover. What you're looking at in that demo there is actually just kind of the default set of policies that come with it. So no doubt, if you run it in your environment for 5 minutes, it'll find something to complain about, and that starts the discussion. It starts the conversation towards solving those problems. So
nice.
Very cool. So I just for everyone watching the show, this is we were on Monday through Thursdays on this channel, Twitch TV/AWS, also YouTube.com/containers from the couch. So if you want to hear us talk, you want to hear about containers on AWS, obviously we go from local container development all the way to our partners and how they integrate with our services. So we talk a lot about containers here. So we hope you'll join us in the future. But thank you, Jonah. Thank you, Chris, for joining today. It was a really great show, and we'll leave it there.
Thank you, guys.
All right. Thanks, everyone.
Thanks.
Take care.
Thanks, everyone.